So we're going to verify that the intermediate value theorem, IVT, applies on the interval, and then find the value of C guaranteed by the theorem. All right, so for intermediate value theorem, the first thing you need to do is find the values on the interval. So my interval is -1 to 2, so I'm going to put -1 into G as well as 2. So I'm going to find G of -1, and I'm going to find G of 2. I have to find the coordinates for each of those. So for the first one, when I plug in -1, I will end up with 9 minus 1, which is 8. And for the second one, I have 9 minus 2 squared, which is 9 minus 4, which is 5. So what we're kind of visualizing here, if we think of a graph, all right, we have -1, that's -1 and 2. There's my interval. And here, let's just say we're going 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And so if I have a coordinate here, I have -1, 8 is one coordinate, and 2, 5 for another coordinate. All right, now my next question is this graph continuous? Meaning, is this function we started with continuous? And yes, it is. It's a parabola upside down. So I'm going to write a note to myself that g of x is continuous. Now, it's always continuous, but for these problems, it wants to be continuous on the interval. So that it doesn't matter if it's discontinuous outside the interval, but it has to be continuous in the interval. So that's a huge stipulation we have to state. So if I know this, and when I find my two values, I know that I can go on. Otherwise, you kind of stop intermediate value theorem. If this is not true, we stop. And then here's our next point in the intermediate value theorem. You have to find the coordinates, how high and low. Now, what is this saying right here? Well, g of c equals 9. What that is saying is we're looking for a value at 9. Is right there. That right there is g of x equals 9. So we're trying to figure out what c value will we cross that green line. Now, if you think about this, if I'm here and I want to get here, is it possible to get from here to here with never crossing the green line? Well, yeah, I could go like that, I could go like that, I go like down and back up like that, all sorts of stuff. To get from here to here, I can't guarantee crossing that, and that's what the intermediate value theorem states. So because I can't guarantee hitting 9, I cannot apply the value theorem, intermediate value theorem, so it doesn't even apply. So really, this question's done. IVT does not apply. So we're done. Now, is it still possible for from here to get to here to hit this? Yeah, I could hit it once. I could go through and back down. It's totally possible, but I can't guarantee. It's all about a guarantee. So I stop saying I can't guarantee anything. It's possible, but I cannot guarantee. Yes, it's continuous. Yes, I know my values, but I can't guarantee touching 9. Now, if we look at it, it actually does work. We're not going to go there, but it actually does hit 9, but it's all about a guarantee. So let me change the problem to something that does work. What if I changed it? What if I made it, okay, on the interval -1 to 2, but I did g of c equals, let's say, let's do 6. So if on the interval -1 to 2, we did g of 6, is that possible? Well, if you look at g of 6 now, well, g of 6 is right there. That's g of 6. So g of x equals 6. So what I'm saying here is to get from here to here, don't I guarantee crossing that blue line? There's no way I can't not pass that blue line, sorry. I can never get from here to here without crossing that. So I guarantee, because it's continuous, I am guaranteed. Here's an example where IVT does apply. All right, so I know it does apply. The key is I changed it to this. That's an if. I made an if statement. So you can't just go make this up. I'm making up a new problem just to show you something. So you can't just, make a new value to choose. No. I'm showing you an example to show you when it would apply. So, all right, next part of the question, if you look up here, is find the value of c where it is guaranteed. So we know it's going to happen, but where? So what I want to do now is I want to set the function, which is 9 minus x squared, and I want to know when it equals 6, right? I want to know when, between here and here, will it cross that? Is it between negative 1 and 2, what value will it cross? So I solve this, and it will tell me that. So to solve this, I minus 9 over. So I now have negative x squared equals negative 3. And then I square root both sides. Oh, no, I don't do that. Take that back. I divide by negative 1. So x squared equals 3. Then I square root both sides. I don't want to, if I did it earlier, I'd have imaginaries. Anyways, so x equals plus or minus the square root of 3. So what this is saying is, at these points, you will cross this blue line. The thing is, are both these dots between negative 1 and 2? Let's think about that. The square root of 3, isn't that between the square root of 1 and between the square root of 4? So isn't the square root of 3 about, well, isn't this 1 and 2? Isn't that closer to 2? Maybe that, isn't that probably something like 1.7 or something? I don't know. All right, so I have basically plus or minus 1.7. Well, 1.7 is right there, but negative 1.7 is out here. That's out of the interval. So really the only answer I want is this one right here, which is the positive square root of 3. So my answer to this specific problem is x equals the square root of 3. That is the answer I would want. That is where, oh, I shouldn't say x. All this stuff I messed up. It should have been c equals, all right? Because we're checking c. So c is the value that when you plug it in, we'll get a 6. All right? I just use x's because that was the equation to begin with. I get x's from here. But when we're doing this, we want it c. So c is the square root of 3. The negative one, again, would be outside of the interval, which we don't care about. And again, intermediate value theorem states is to guarantee. So once we stated this, we got a guarantee because it's continuous. And then we find out where by setting the function equal to that. All right, it's all about a guarantee to help you know you can go on instead of doing all this work for nothing.